Assalamualaikum and good morning everyone. My name is Muhammad Ashraf Asri, metric number CD190122. Today I would like to present to you about my FRP project is prediction of fluid pattern in a membrane reactor for biodiesel production. First of all, I would like to be thank to my supervisor, Dr. Nurul Fiti Nasir, and I'm also like to be thank to Encik Suzairin and Dr. Sharin for being on my panel today. Okay, I would like to start with introduction. Okay, for the introduction is the recent increase in the price of crude oil, the depletion of fossil fuel reserve, and environmental concerns have all raised grave concern. In 2012, the world consumed up to uh, 12 million tons of oil equivalent, of which 87% came from fossil fuels. Malaysia has experienced an increase in energy demand as a result of the nation's development and economic growth. Currently, biodiesel is one of primary alternatives to diesel derived from petroleum. Biodiesel appears to be a promising alternative due to its eco-friendly characteristics and nearly equivalent performance to fossil fuel. The purpose of utilizing new energy sources is to ensure the nation has access to a reliable and secure energy supply. The energy demand and supply are also discussed in relation to the country's full diversification policy and their respective source. The study evaluates Malaysia's current energy and biodiesel market as well as the country's economic, social, and environmental strength and biodiesel production. In addition, the country's potential to become a leading producer of biodiesel is investigated further. The focus of the investigation is biodiesel production in Malaysia. Palm oil is the primary raw material for biodiesel production because Malaysia is one of the largest producer of palm oil. By developing biodiesel production in Malaysia, it's hoped that not only will the country energy needs to be met, but Malaysia will become global leader in the biodiesel industry. Next is I would like to talk about biodiesel. What is a biodiesel? Biodiesel is an alternative fuel similar to conventional or fossil diesel. Biodiesel can be made from the vegetable oil, animal fat, tallow, and used cooking oil. Transesterification is the process used to transform this oil into the biodiesel. The largest source of suitable oil is oil crops such as rapeseed, palm, and soybean. Currently, the majority of biodiesel is produced from waste vegetable oil sourced from restaurant, chip shop, and industrial food manufacture such as Bird's Eye. Although oil derived directly from agriculture represents the greatest potential source, it is not produced commercially because the crude oil is too expensive. After the cost of conversion to the biodiesel is factorized, it is simplified to the expensive to compete with fossil diesel. Oftentimes, using a vegetable oil can be obtained for free or for a nominal fee after having been treated. In order to remove impurities, waste oil must be treated prior to biodiesel production. The end result is the biodiesel made from a used vegetable oil can compete with the fossil diesel right now. Okay, next I will share to you about a benefit of biodiesel. This is a 7 benefit of biodiesel. First of all is positive economic impact. Second is cleaner biofuel refinery. Third is biodegradable and non-toxic. It can reduce further oil dependency and it better fuel economy and produce from renewable resource, less greenhouse gas emission. Okay, biodiesel has a lot of features that are good for the environment. The fact that the biodiesel is a carbon neutral is a main advantage. This is indicate that there are no net carbon dioxide emission from the fuel of CO2. This effect happens as a result of the oil crop absorb the same amount of CO2 that released when the food is burned while it's growing. In the actuality, this is not entirely accurate because CO2 is released during the fertilizer production, which is necessary to fertilize the field where oil crops are grown. The esterification process, solvent extraction of the oil, refining, drying, and transportation are additional sources of the pollution related to the production of biodiesel. Fertilizer production is not the only source of the pollution. All of these processes need energy input, which can come food or electricity, both of which typically release a greenhouse gas into the atmosphere. Okay, next is biodiesel production. Biodiesel can be produced from the straight vegetable oil, animal oil, fat, tallow, and waste oil. There are three basic routes to biodiesel production from oil and fats. First is base catalyzed esterification of the oil. Second is a direct acid catalyzed esterification of the oil. And third is the conversion of the oil to its fatty acid and then to biodiesel. Okay, the classification process is the reaction of the triglyceride fat oil with alcohol to form ester glycerol. Uh, Triglyceride has a glycerin molecule as its base with a three-alone chain fatty acid attached. The characteristics of the fat are determined by the nature of the fatty acid attached to the glycerin. The nature of the fatty acid can turn the effect of the characteristic of the biodiesel. During the esterification process, the triglyceride is reacted with alcohol in the presence of the catalyst, usually as strong as alkaline, like sodium hydroxide. The alcohol reacts with the fatty acid to form a monoalkyl ester or biodiesel crude glycerol. In the most production, methanol or ethanol is the alcohol used. Methanol produces a metal ester, ethanol produces an ethyl ester, and is the base catalyzed by is the potassium, sodium, and hydroxide. Potassium hydroxide has been found to be more suitable for the ester biodiesel production. Ester base can be used for the metal ester. A common product of the translocation process is a red metal ester (RME) produced from raw resin oil reacted with methanol. I will show you the figure that chemical process metal ester biodiesel and the reaction between the fat oil or the alcohol is a reversible reaction, and so the alcohol must be added to access to the drive reaction toward the right to ensure the complete conversion. Okay, for the biodiesel production, feedstock. Biodiesel is a renewable fuel made from various feedstock including the refined vegetable oil, recycled cooking oil, and rendered animal fat. As you can see, we got four types of generation about feedstock. First generation feedstock is most likely edible oil, feedstock that come from raw material and such as oil extraction. And the second generation feedstock is non-edible oils, feedstock that easy to find and renewable. And the third feedstock is a very uh, eco-friendly because we can use it as a recycle, such as waste oil collection, algae cultivation. Okay, for the fourth generation feedstock is advanced solar oil, such as genetic modification, energy utilization, and harvesting. Okay, this is what I said about the classification process. Almost all biodiesel is produced using a base catalyzed classification as it the most economic process requiring only low temperature and pressure and producing 98% of conversion yield. Okay, as you can see, we use waste cooking oil for this project and react to the methanol as a catalyst. Next is a catalyst that are used for a biodiesel production. In order to achieve effectiveness transesterification, catalysts are important, and the velocity of the reaction is speed up by catalyst, while at the same time the condition of the reaction and its temperature are lowered. The most frequent type of the catalyst are acid, base, and enzyme. This may all be further categorized according on the whether or not they are homogeneous or heterogeneous. As you can see on the left, we can see the figure of the setup of our catalytic membrane. Catalytic membrane, the reaction of the chemical are being studied in the membrane reactor will be produced by biodiesel. Okay, next I will talk about membrane reactor that I use it in this topic. A membrane reactor is a device that combines reaction and separation into the one unit. The significant difficulty in the separating and purifying fatty acid metal ester (FAME) biodiesel production using this reactor is a novel concept designed for the most environmentally friendly environment. Okay, why I choose membrane reactor? Because membrane reactor has a several advantage. The first advantage is environmental friendly process, and it has a lower investment cost. And third, it overcoming the limitation caused by a chemical equilibrium. And fourth is high process flexibility of feedstock condition. So I can use a lot of feedstock, a lot of waste cooking oil to study about this process. And lastly, comparing with the internationally standard. Okay, what is a ceramic membrane reactor? It's a new technology for producing a biodiesel. Is the that provide viable alternative to a traditional biodiesel manufacturing procedure, which have a number of drawbacks. Okay, next is the process that will affect the production of biodiesel. First is the reaction temperature. Second is methanol that are used for the biodiesel. Second, the effect of catalyst concentration. And fourth is a rate of flow rate. Last is transmembrane pressure. So all of this will affect our result and output for this study. Okay, for the objective of this study is to investigate the fluid flow and the velocity profile inside the membrane reactor using safety software. The next is to predict the yield of the biodiesel produced in the membrane reactor at a different reaction condition. The scope of this study is the reaction temperature is very from 60 to 70 Celsius. The catalyst concentration is very from 0.5 to 6%. Reaction reaction time is set at 6 hours, and camber membrane is used as the reactor, and the sulfuric acid is used as catalyst. The factor that influence the reaction is the chemical approach. Transesterification process catalyzed by the various catalysts is used to make this biodiesel. There are three types of catalysts. One is homogeneous, heterogeneous, and biological. I already designed the membrane reactor in the SolidWorks and study using ANSYS. The setting of this software, the reactor is covered which is vary from 60 to 70%, and the catalyst sulfuric acid concentration is vary from 0.5 to 6%. Okay, this as you can see, my model drawing and machine process. This is ceramic catalytic ceramic membrane reactor that I draw using SolidWorks, and you can see the design and the machine process. Okay, to summarize the simulation configuration that I do is, first is I use CFD. For solver preferred, I use fluid, and the sizing I use The sizing I use advanced function, proximity and curvature. The relevant center I use fine, and smoothing I use height. Okay, for the option, uh, I get the operating pressure is about 101.325 Pascal, and density of this study is 0.693 kilogram per meter. The surface tension is 0.01628. Next is processor, ceramic ceramic membrane reactor that I use it in geometry and physical condition. First is side of membrane reactor. I use 416 millimeter and times by 50 millimeter. The size of inlet pipe is 10 diameter, and the outlet is 20 diameter. The mesh flow rate that I use is on the 4 gram per minute, and the phase is oil and vapor. The pressure that I use is 0.5 megapascal. As you can see, the thermal and physical property of material. The material that I use is methanol at 330 Kelvin, with cooking oil in the temperature 330 Kelvin. The density of methanol is 792 kilogram per meter, and the viscosity is 0.00345. The density of the waste cooking oil is 919.7 kilogram per meter square, and the viscosity is 0.000221. The surface tension of the waste cooking oil is 0.0232. Next is conclusion. The conclusion for this project, I can conclude for the PSM1 is membrane technology is economical and effective method for biofuel production, as well as offer high selectivity and high surface area to volume ratio. Second, biodiesel production from waste cooking oil is environmental friendly, for it recycle waste cooking oil and give renewable energy which lower pollution. It substitutes some amount of petrochemical oil import and also lower cost of waste management. Biodiesel production from waste cooking oil has three solutions that are economic, environmental, and waste management. Third is the use of membrane reactor is more economically sustainable than a conventional reactor. That's why I use membrane reactor. Uh, Last but not least, using biodiesel substantially reduce emission of particulate matter of an unburned hydrocarbon. Using biofuel is simply better than using fossil fuel, because right now our food is the price is going up, so it's very not uh, environmental friendly also. Lastly, the production of biodiesel via a catalytic membrane reactor is indisputably and environment friendly process when compared to the more conventional method of producing biofuel. Okay, that's all for me. Thank you.